Okay, so in this video, I will show you how to use this bare segmented LCD display directly with the Arduino UNO or any other Arduino board. And I actually bought this display about 3 years ago, right when I started this channel, because I thought this will be a simple project, but of course it wasn't. Because LCD displays, if they don't have any driver chip, which is the case of this display, there is no chip, it's just a bare LCD display, they require AC, the alternating current, and Arduino only provides DC, the direct current. You know the ground is always ground and the 5 volts is always 5 volts, nothing is changing, nothing is alternating. That said, I can use ground and 5 volts from the Arduino directly with the display. If I connect the ground to the command pin, which is the one on the left side of the display, and then touch the other pins with 5 volts, I am actually lighting up those segments, and they stay visible for some time after disconnecting those wires. But again, those two wires, this is DC, direct current coming from the Arduino, and if you connect the LCD display to the DC source for long enough, you will eventually damage the display. So what we want to do instead is to use AC, the alternating current, which means that we want to connect the command pin to the ground and then the segment to 5 volts, and then we want to switch it, so the command pin to the 5 volts and the segment to ground, and then again ground 5 volts ground, ground 5 volts, and so on and so on. Obviously I cannot do this fast enough with just my hands, so let's do that with Arduino. And actually before we do that, let's talk about the sponsor of today's video, which is PCBWay. And that's because if you are making electronic projects, sooner or later you might need custom PCB or PCB assembly or SMD stencils, and PCBWay has you covered. They offer all of those services for a reasonable price. And since you've already seen the project in the beginning of the video, you already know that I'm using a lot of wires, so I thought let's simplify this a little bit and use a custom PCB for that. And if I make the PCB as the Arduino UNO shield, I can then later on snap it to the Arduino board and then connect the display to the PCB. On the PCBWay, you can get 10 of those PCBs for just $5, but if you use the link down in the description, you can get them for free, only paying for shipping. So thank you PCBWay, and let's get back to our project. So once again, what we want to do is we want to apply ground to the command pin of the LCD display and then 5 volts to some of those segment pins, and then we want to quickly flip it around. So ground will be connected to the segment pin and the 5 volts will be connected to the command pin. So let's create a new sketch in the Arduino IDE, and since we want to set ground or 5 volts for some of those Arduino pins, we need to first inside the setup function set them as output using the pin mode function, so pin mode, and let's for example use the pin number 2 for no particular reason and set this one as output, and let's use the very same thing for the pin number 3. Then inside the main loop we want to set the ground to one of those pins. And for that we can use the digital write function for the pin number 2, and if we set this pin to the low state, it will be set to ground. And then for the other pin, the pin number 3, we want to set this pin to the high state, and in that case the high state means 5 volts. Then we want to wait for a very small time, for example only 10 milliseconds using the delay function. And then after that we want to switch the sides, so for the command pin, for the pin number 2, we will set it to high state, so we will set to 5 volts, and the other pin, the pin number 3, we will set back to low state, so back to ground. And I think that's all that we need to do to simulate AC, the alternating current, so let's just select the Arduino UNO from the drop-down menu and upload this sketch to the Arduino by hitting the upload button. And since this sketch is very simple and extremely small, it should only take a few seconds. So with the sketch successfully uploaded, let's connect some jumper wires to pins 2 and 3. And let me actually use the different colors of those wires, because those are no longer ground and 5 volts. They are changing all the time. And if we now connect one of those wires to the command pin, which is the one on the very left side, and the second wire to any other pin, we can light up those individual segments. And the pins might be slightly confusing because we have 20 pins for a 7-segment display with 8 segments, so 7-segment digit with the decimal point. But each set of 2 pins is actually connected to the same segment. So the first 2 segments are the common electrode, then the next 2 pins are 1 segment, then the other segment, the third segment and the decimal point, and it works the same way on the top pin header. The first 2 pins are common electrode, and then the segments 5, 6, 7 and 8. And I think that we should have enough pins on the Arduino board to connect all those individual segments. Usually we should avoid using pins 0 and 1 because those are used for the serial communication between the PC and the Arduino board. So let's use the next 9 pins from pin 2 all the way to pin 10 to connect all those 8 segments and one common electrode. In the end, the connection might look something like this. And we are already lighting up one of those segments. So let's update the Arduino code to light up all 8 segments, and then later on we will show some digits. To display all the segments, we need to expand the Arduino sketch, starting with setting the outputs for all the pins. That's for pins going from pin 2 all the way to pin 9. And then in the first half of the loop, we will still keep the common pin to the low state to the ground, and all the other pins to high state to 5 volts. And then we will flip it around, so the common pin will be connected to 5 volts and all the other pins will be connected to ground. And with this change, let's try to upload it again to the Arduino UNO board. And if everything is connected properly, we should see the digit 8 together with the decimal point, so all 8 segments are visible. So how do we not show the segment? And one way is of course to disconnect the wire, disconnect the connection. But if we want to not show the segment with the wire still connected, we want to set the state of this pin to the same state as the common pin. So when the common pin is low, it's ground, the segment should be also low, also ground. And when the common pin is high, it's 5 volts, the segment should be also 5 volts. That way the voltage difference will be 0 volts and the segment should not be visible. So let's actually try that in the Arduino sketch. Let's randomly pick one of those segments, for example the segment connected to pin number 9, and set it to the same state as the common pin, so the common pin is low, and therefore also the pin number 9 should be low, and in the other half the common pin is high, so our pin number 9 should also be high. And let's just delete those comments so it's not misleading, and then try to upload it to the Arduino one more time. And indeed, one of those segments is now invisible, that's this segment, which is coincidentally forming the digit number 6. Now before we move on to displaying other digits, we need to identify which segment is connected to which pin on the Arduino. I was able to find this image, which shows the connections inside the display. So the segments are connected like that, and then I just need to trace to which Arduino pins are those segments connected. So let's keep those connections in mind and jump back into the Arduino IDE. In here, let's create custom names for those pin numbers by typing define, like so, and call it segment common, and it will be the pin number 2. And then segment going from segment A all the way to segment G and the segment decimal point. And of course, I'm looking at the image to see to which pins are those segments connected. Then we will use those names inside the setup function. And of course inside the main loop function. Now when we know the segment names, let's for example show the digit 2, starting with displaying all the segments. And then we don't want to show the segments C and F, so the C should be same as the common pin, as well as the F segment. And it should be same down here, so the C segment should be high as the common pin, and again, same as the F segment. Then upload it one more time. And indeed we have the digit number 2. Now we can continue like this with all the other digits by putting low and high states in multiple places, but I think it will make more sense to save those values somewhere in some kind of array. But how do we save those high and low states inside the array? Well, it turns out that the same way we have said that, for example, the number 4 will be called segment D, someone else decided that instead of setting the pin using the digital write function to either 0 or 1, we can as well type in low and high because it might be more readable and understandable. But same as in our case, once we compile the sketch, the segment COM will be replaced by number 2, the segment A will be replaced by number 8, and high will be replaced by 1, and the low will be replaced by 0. And we can as well control click on those names and it will open the arduino.h file, and you can see that we have this defined for the high state being 1 and the low state being 0. So we can as well go back into our main sketch and replace all the highs with ones and all the lows with the zeros. And this will work in the very same way. So let's create a new array, and it will be the array of integers, and let's call it segments digits. And it will be actually a two-dimensional array because we need 10 entries for digits going from 0 to 9, and for each of those digits we need 8 segments. And those segments are of course A, B, C, D, E, F, G and the decimal point. So let me quickly type in all those entries, and for now I will use all the zeros, so 8 zeros for every single entry. And we need that for 10 digits. And of course don't forget about the last semicolon. And then open the reference image for the 7-segment display and start filling those values. So for example, for the digit number 0, we want to set all the segments to 1 except for the segment G. For the digit number 1, we want to only show segments B and C. And so on and so on. You can see that right now I'm not setting the decimal point, but I might change this later on. So when we have all the segments stored inside the array, let's actually use that array inside our drawing function inside our main loop. So we will set the segment A to the first segment of the segment digits, and the first index is the actual digit, so let's create a new variable of the type of integer and let's call it a digit, and for now set it to 0. And then use this variable as the first index, and then copy this array name into all the other segments and increase the second index. And then in the second half of our drawing function, we want to again use the value from the array, but we want to have the opposite value. So for example, if the value of this integer is 1, it should be 0, and if it is 0, it should be 1. And we can of course use the if statement, but a better way would be to use the exclamation mark. So if we type in the exclamation mark, it's the logical NOT function, so if the value is true it will be false, and if it's false it will be true, but it's the same for 0 and 1, so if it's 1 it will be 0, and if it is 0 it will be 1. So let's use the integer values from that array, but again this time with the exclamation mark in the beginning. And with that change, let's try to upload it to the Arduino UNO board. And just because we've set the value of the variable digit to 0, we should see the digit 0 on the display. With that said, we already have the values for those individual segments stored inside our array, so let's just increase the value of the variable digit and count from 0 to 9. And we cannot just increase the value of digit with every iteration of the loop, because the content is going way too fast. It's going, I don't know, maybe 20-30 milliseconds. So we need to wait a while before we increase the digit, and for that let's create a new variable and call it for example frame. And instead of increasing the digit, let's increase the frame, and if the frame is above some number, if the frame is for example bigger than 200, in that case then we will increase the digit, and if of course the digit is bigger than 10, we will go back to 0 and set the frame back to 0 as well. And this semicolon should be inside the brackets, not outside, and of course we want to set the digit to be 0. And actually, you know what, maybe we can make it slightly faster by not counting up to 200, but only to maybe 50. So let's upload it to the Arduino to see what happens. The display is now counting from 0 all the way up to 9. Again, I'm not showing the decimal point, but you can easily change it by changing the values inside that array. Now, since everything works as expected, let's talk about the memory usage and some possible optimizations. Right now we are using integer values to store the values of those individual segments, either 0 or 1. And on the Arduino UNO, the integer value is taking 2 bytes. So you can set the value to this range, which is kind of big range considering that we only need to store 0 or 1. And we can do a quick math. We need 10 digits, and for each digit we need 8 segments, and the integer takes 2 bytes. Which means that for this array alone we need 160 bytes. And this is kind of aligned with this information, so we are using in total 173 bytes, but out of those 173 bytes we are using 160 bytes for this array alone. Now one of the very simple optimization would be not to use integer, but instead to use byte. because the byte only takes 1 byte as the name suggests, and you can only store the value going from 0 to 255, but again that should be perfectly fine because we only need to store values 0 or 1. So if we go back into our sketch, we can change the integer to be byte instead, and now if we compile the sketch again, you can see that now we are only using 93 bytes. And it all makes sense because we need to again store 10 digits times 8 segments times 1 byte per segment, which is of course 80. So we are using 80 bytes for our array and then 13 bytes for something else. Now we can optimize this even more because again the byte goes from 0 to 255, but in our case we only need to store zeros and ones. And actually the byte is made from 8 bits and we can use those bits to store zeros and ones. So instead of having 2-dimensional array, we only need 1-dimensional array for the digit going from 0 to 9, and then we will store all those digits, all those values inside 1 byte. And we can get the correct values by plugging in those bytes. So for example, for the digit 0, it will be 11111100, which is a decimal value of 252. But what we can do inside Arduino is to type in capital B, which stands for bytes or bits, and then we plug in those bits, so 1, 1, 1, 1, 1, 1, and 0 and 0. So this is 1 byte made from 8 bits. So let me change it in the same way for all the other values. And since this is now 1-dimensional array, we don't need those extra brackets. And we should have our array ready and prepared. Now of course if we read the value of this array, we will get the whole number, all 8 bits or 1 byte, but we want to somehow extract individual bits for individual segments. And thankfully there is a function for that in the Arduino which is called bit read, and that will read the bit from the byte, so our byte will be segment digits on the index of digit, again this is only 1-dimensional array. And we want to provide the index of that bit, and by default it's counting from the right side to the left side, so this is the index of 0, 1, 2, 3, 4, 5, 6 and 7. So for our segment A we want to use the index of 7, so the bit of the index of 7, and then for the next one we will use the index of 6 and so on and so on. For the next half of our drawing, our loop, we will use the very same code, but this time of course with the exclamation mark in the beginning to invert the value of the read bit, like so, and then try to upload it to the Arduino and see how the memory usage has changed. And you can see that now we are only using 23 bytes, which is quite a difference from the initial 173 bytes. And of course there shouldn't be any difference on the display, it should still count from 0 all the way to 9 and then again and again. Now our solution works, but of course it has one big downside. We need to update the display as fast as possible, which means there is very little computing power to do anything else. And that's of course why using a dedicated LCD driver chip might be a better option. If you are interested in more details about LCD displays, the EEV blog has some nice video series, I will put the link down in the description. If you want to know how I made this PCB, that Arduino shield, I have a few videos on my channel describing the process of creating the Arduino shield inside the KiCad. I will put the links to all of those videos inside the description, as well as the source KiCad files, so you can just open them and see them by yourself. As always with creating a custom PCB, I did start by exporting the PCB in the SVG file format, so I can use my laser engraver and cut it from a thick piece of paper. This is a 1mm thick paper, which is almost the same thickness as the PCB, but it could be cut on pretty much any laser cutter. And since I can also cut all those individual holes, I can test fit if the LCD fits the PCB. And since this was a perfect fit, here is the finished PCB, which is exactly the same dimensions and size as the paper version. Actually, there's one small difference. I did move the placement of the LCD slightly, so the pins are not touching anything on the Arduino board. Here is the PCB with all the pins soldered. For this version, I've soldered the LCD directly to the PCB. And I also have this version of the PCB where I've soldered the female header pins instead. That way I can just snap the LCD into those pins or remove it if I want to. For both versions, I had to slightly tweak my Arduino code because those connections on this PCB are slightly different than in my original code. The only reason for that was to simplify connections on the PCB. And that's pretty much it for today. If you have any questions or comments, please put them down in the comment section. Thank you very much for watching, and I hope to see you soon. Thanks and bye.